Question 2 on the practice questions is a product of a x to the power of 2 multiplied by a trigonometric function sine x. So once again, we have our rule, the integration by part rule, which is u dv is equal to uv minus the integral of v du. So we need to decide, first of all, what are we going to pick as u. So following our rule number 1, if one of the factors is a log function, well, it isn't, so we skip to rule number 2. If there's no log function but a power of x, this is taken as u. So that's our answer. We take u to be x squared. dv is equal to sine x dx. We differentiate u on the left-hand side here, so du dx is equal to 2x. And that implies that du is equal to 2x dx. So we have the du that we need for our formula. We also need to get v. So we integrate both sides here. The integral of dv is the integral of sine x dx. Therefore, v is equal to minus cosine x, and that is our v. Applying our integral rule then, u is x squared, dv is sine x dx. So that's our u, that's our dv. And that is equal to u, which is x squared, times v, which is minus cosine x, minus the integral of v, so it's minus cosine x, and then we have du, which is 2x dx. So if we tidy this up, we have minus x squared cosine x, and on this side, the minus and the minus here, this minus multiplied by that minus gives us a plus. I take this constant 2 outside, and I'm left with the integral of x times cosine x dx. And this we will call equation 1. And the next step then is I have to take this and I have to integrate this. So just if I put a line here just to break it, and we're starting again, x times cosine x dx. Now I'm leaving the definite integral off for the moment, I'll just put it in at the end. You know, it's from pi over 2 to 0, but I'll put that in at the very end. So I'll just do it as an indefinite integral to begin with. So following the same rule we did before, the second one here applies. We have x to the power of 1, so we say u is equal to x. That means du dx is 1, and that implies that du is equal to dx. If I come over here, dv, u is x, therefore dv is cosine x dx. If I integrate both sides of this, cosine x dx, that implies that v is equal to sine x. So if we apply our integration rule again, u dv, so that's x times dv is cosine x dx. U dv is equal to u times v, so it's equal to x times sine of x minus the integral of sine of x, and now du here is, that's v, and du is dx. So now we're in a position to integrate this final term straight away. The integral of sine x is minus cosine x. So if I take that, minus cosine x, and I plug it in there, we have minus times a minus, so we have x sine of x plus the cosine of x. And this I'll call number 2. And then of course the next thing is we have to substitute that into equation 1. So if I come along here and I take equation 1, I'm going to skip these steps here. If I do it down below here, equation 1 is x squared sine x dx is minus x squared cosine x plus 2 times the integral of x cosine x dx, which is what we have up above. So this is my equation 1 here. And I'm going to substitute 2 into 1. So that tells me that's equal to minus x squared cosine x plus 2 times, open up brackets, and I'm going to take this one here. I'm going to substitute it in. So it's x sine x plus cosine x. And I'll skip beyond the box here. If I just come down below, that means the integral of x squared sine x dx is minus x squared cosine x plus 2 times x sine x plus 2 times cosine x. Now that's normally with a constant of integration, but we know we have definite integrals here. We're going from pi over 2 to 0. So that gives me the integral from pi over 2 to 0 of x squared sine x dx is equal to, so I'm going to plug the values in straight away. It's, no, I'll do it out, minus cosine x plus 2x sine x plus 2 cosine x, and that's going from pi over 2 to 0. So to kind of speed this up, what we can do is we can, first of all, before we put the values in, we can work out the cosine of pi over 2 is 0. Cosine of 0 is 1. And alternatively, the sine of pi over 2 is 1, and the sine of 0 is 0. It's because we have cosines and sines in our answer here. So if I just put that in the box there, we have it ready to go. So that means that is equal to minus pi over 2 to be squared. I'm putting in the upper limit now. So the upper limit is pi over 2. So it's pi over 2 to be squared, cosine pi over 2, plus 2 times pi over 2 times sine of pi over 2, plus 2 times cosine pi over 2. And then this is minus, and once again, now it's 0, so we're plugging in 0 for, so it's minus 0 squared cosine of 0, plus 2 times 0 times the sine of 0, plus 2 times the cosine of 0. And I'll just put it above these, I'll put what the values are. Cosine of pi over 2 here is 0, so for all of that goes to 0. The sine of pi over 2 is 1, so what we're left with here is, if I do it here, I'll just bring it down here. We have 0 for the first one. I'm bringing this lot down in here. So 0 for the first one, and then we have 2 pi over 2 times 1, where sine pi over 2 is 1, plus 2 times 0, because the cosine of pi over 2 is 0. So that goes to 0, and that goes to 0. And then we have minus, I now look at the lower limits. So obviously this one here is 0, this one here is 0, and this one is 2 times 1. So what we're left with here is, we look at it, is that's pi, and here we have, that's pi, and here in the lower limit we have 2. So that gives us a final answer of pi minus 2.